So power series, we looked at the geometric series yesterday, right? And that converges for what values of x? Do you remember when we did the original geometric series that actually had a sum? What was that sum? So you got the formula in their head yet? 1 over 1 minus r, right? R was here, so now we just have an x. Okay, so series, geometric power series and geometric series, same thing, right? One just has a variable, one has a number. Okay. The nice thing about this is it generalizes it for all x values. Okay. So same thing, but we can use that information to show that some series are geometric series and what their sum is. Okay. So you might see something of this nature.
Would that simplify to 2x n plus n?
This?
Yeah.
What did you say?
Would that simplify to 2x to the power of n plus n?
No plus n. They have different bases, right? So we do not add the exponents. But if they have the same exponent, we can combine the bases. Right? So don't mix this up with that. Same base, different exponent. Now we're going to do addition, right? Versus same exponent, different base. We just follow the operation between them, put them together. Does that help?
Yeah.
Okay. So he's thinking on the right lines on to how to prove this problem is true. Okay. So we've rewritten the series. What do we know that this has to be for that to converge? If we look at our geometric series. Right, this has to be less than 1, right? So same thing here. So we need the absolute value of 2x to be less than 1. Right, see the parallels there. And then a little bit of division, right? And we also can substitute 2x in for this right here. Okay. So you just basically by rewriting this and showing your work, you're proving that that is true. Okay. It's pretty straightforward. But it is one technique that some people make it miss. You make it easier, just manipulate your exponent rules. Right? Just like we've been doing. good on that? Okay. Let's talk about series expansions. So we already wrote e to the x up, right? Make sure I wrote that down right. Oh, it's got to be 0. I think I goofed that. Put 0 right there on your card.
I put 0.
Okay. So, this is probably going to be very obvious to you. What is the derivative of e to the x? Right, okay. It's the same thing as differentiating term by term, right? So we know that as e to the x. What's the derivative of 1? 0 plus, and then if I put x cubed over 3 factorial, right, it'd be x squared over does that make sense? Just term by term, that's all you do. Okay. If I want to integrate, I'm going to do it term by term. Okay. So it's very straightforward, derivatives and integrals of some of these functions and the power series. Okay. And it can be pretty handy, like I pointed out to you over there. The nice thing is, e to the x converges for all x values. Okay. The really nice thing is the derivative also converges for all x values. The convergence does not change if you differentiate or integrate. Okay. And this works for derivative. So either of those, same convergence, doesn't change. Woo! Yay. Makes it real simple, right? Let's look at something. This prove for this is not as obvious what you need to do on this one. Okay. But when you see something, so this is not a series that you will have memorized. So if you see a non-standard series like this, your alarm bells should go up and think, I have to do a derivative or an integral. Okay, so if this is that worked very well. So again, if you see something that we don't have memorized, quote, that's probably going to be a derivative or an integral of something that we have memorized. Okay. Does it look oddly familiar to one of the ones we put on the board over there?
1 over 1.
Right. So 1 over 1 minus x is what? 1 plus and converges for what?
That's absolutely it.
Yeah. Does that match? Yeah, same thing, right? So how can I get from here to there?
Well,
Yeah, the bottom needs to be squared, right? What if I write it like this? And this one would be, can you get from here to here with, that's a derivative, right?
well, you can cut that by the series, the individual parts of
Yeah, you can, and you can see the individual parts also, right? So if I derive that, you're going to get 1 minus x to the negative 2. So you bring it down, subtract 1, and then the chain rule requires that we have another negative, right? So we get 1 over 1 minus x squared. Okay. And then derive term by term. 0, right? Plus 1 plus 2x plus 3x squared. Okay. Those two match, correct?
Yep.
And we know that there's a theorem in your book that says that these doesn't change at all. Okay. It's a pretty handy tool. That's what it sounded like, isn't it?
I think it was
Okay. So, and we can do this any number of series. All right. The trick there again is to see that and know that it's not a standard series. You could probably obtain it from a derivative or an integral of another. Okay. Good? I think so. All right. Okay, here's one more little thing that makes life a little easier. Okay, so we just wrote that one down. Is the series expansion for 1 over 1 minus x squared. Notice there's no parentheses this time, right? It's a different style of problem. How do I get from the top one to this one? What's the difference?
X squared.
Yeah, I can substitute an x squared in there, right? So what am I going to do with that? Yeah, 1 plus x squared squared, right? We just directly substitute. Okay, so this in fact is so all your rules apply from algebra. You can directly substitute, it still works. You can, and then calculus, integrate, differentiate, term by term. Okay. Okay. Any questions? All right, so geometric series, and then we're looking at expansions of series, derivatives, integrals, and substitution. Okay. That's all I got. Do you want me to write the work down again? Or are you good? Again, it's not due until Friday, so you got a couple days to finish up and do the packet there. There you go. Friday and Tuesday will be Taylor series. Wednesday, I think, is test review day. Thursday, test. Friday is grading. So we're almost there on this unit. Okay. Taylor series won't really throw anything new at you that you don't already know from polynomials and power series. Okay, so good stuff.